Today, our speaker is David Dunér. He's professor in history at the University of Lund in Sweden, and has actually a sabbatical at the moment at the University of Uppsala. So he's coming from the third oldest university in Sweden to the oldest one at the moment. David, the floor is yours, and I will try to do my best and make it as presentable as possible.
Okay, thank you. Yeah, thank you very much for listening. And I'm, of course, sorry about the delay and the technical problems. And today I would like to talk about the history and philosophy of biosignatures and some historical and philosophical issues involved in the search for signs of life. If we go to the second slide I have, you could say that the most likely scenario is that we will find, it will not be that we will find life as such, something that we can hold in our hand or study in the microscope or that thing. The most likely scenario is that we will find signs of life, remote indices or biomarkers or biosignatures of or traces of life. So we will not be able to perhaps study life in itself, but the signs or remains of life. And so that's the most likely scenario, and that it might be possible that we will find life in that kind of way the next few decades or so, or perhaps even right now when the Perseverance rover is rolling around on Mars. Maybe it will find signs of dead life or extinct life on Mars. So, but what interests me is the philosophical problems around this, how we could be sure that what we find is actually life or remains or traces of life. How could we rule out other explanations for this connection between the sign and the content that is life? So a definition of biosignatures are biochemical processes that could have their origin in extraterrestrial biological activity. So we are searching for unknown instances of known biochemical processes. And we suppose that these signatures are caused by that we call life. So what we do is make up a connection between the expression, that is the biosignature, and the content, the living organism. And those who make this connection between expression and content are we human beings. We are the interpreter of this sign relation. But how could we be sure that there is a real link between the sign and the content? And that's the challenge for the study of biosignatures. And in that, it involves a number of philosophical problems that I would like to address today, that I think we need to address and think that we need to discuss how we could make us more sure about the conclusions we make from the information we get. So how could we know? That's the main question for me today. How could we know? How could we be sure? How could we get knowledge about something that we don't know anything about? And that's the real challenge. So if we go to the next slide, we have actually in the literature in astrobiology, we are using the concept biosignatures, and it is used for a number of different kinds of phenomena, a vast variation of very different things, actually. So biosignatures concern chemical substances. It could be elements, molecules. It could be also physical features, structures, shapes, morphology. And it could also be physical phenomena like electromagnetic radiation, light, temperature, etc. So it's very different things that we call biosignatures. And they can vary in scale from atomic to planetary magnitude, perhaps even bigger than planetary magnitude. So they could also be searched in situ on the very spot, on Mars, for example, on other planets. But it could also be through remote indirect sensing, with the help of spectroscopy, for example. And it could be, these biosignatures could be evidence of living life or dead life, present or past life. So what I mean with this is that when we are talking about biosignatures, it's a very different kinds of phenomena we are discussing or studying. So what I aim to is to find a more order among this chaotic variation of science. And maybe philosophy and semiotics could be a way of trying to find a more rigor order among these different kinds of phenomena. So if we go to my first question, if we could go to the next slide now. I have actually 4 philosophical questions today that I would like to discuss. And the first is obviously the concept of life. As scientists, we are using concepts in order to talk about that thing we are studying. We need concepts and some certain degree of agreement among us when we using our concepts. And perhaps the most widely discussed philosophical questions in astrobiology is the question of what is life, the definition of life. And there are many attempts to find a definition of life, and it's based on a number of different characteristics that we connect with life. Usually some specific organic molecules that we think is characteristic for life. It could also be metabolism, reproduction, that life is something that reproduces or make copies of itself, and it's also endowed or is involved in an evolutionary process. So there is a number of phenomena that we connect with life. The question is that how could we be sure if this definition we have is the best one that will cover all future instances of discoveries of potential life. And perhaps the most popular and common quoted definition is the NASA working definition, that it says that life is a self-sustaining chemical system capable of Darwinian evolution. And it has three difficulties. This question of the definition or the concept of life. It's the first is the question of what is a definition. If you go to this slide, the definition of definition, the most common way, the most common sense way of approaching the question of the concept of life, it's seeing it like a recipe, as a number of ingredients that need to be in place in order to make up this cocktail that life is. That there is a number of specific characteristics that it must be included in something to be life as we know it. So that could be called an Aristotelian definition of life. That is, it's a limited list of characteristics. Other ways could be to stress on family resemblance. You can connect it with Wittgenstein's idea that there are a family resemblance between the instances that we call life, that there are not all of them sharing the same characteristics, but they share parts of it. And the third way of trying to find a definition is a prototype theory, according to Roche, that we have in mind actually a prototype or a perfect type of life. That's what we are using in the species concept, for example, that we have prototypes or type specimens in biology that is from that we call the most perfect example of that kind of life. And we have a prototype of life, and that is our own life, the life we find here on Earth. That's a kind of prototype for life that we're searching for. But the question is, if we are searching for life, or have a definition of life, it should encompass all the life we know. But it should also be anticipatory. It should also be possible to use that definition for future situations, that it could include unknown life. So that's the challenge when we have a different, when we are trying to find life. So if we go to the next slide, what everything is about is that we are using categories in science, and that we are, as human beings, we need categories. We need definitions, finding hierarchies and similarities between things. That's the way we are treating things. We can't just observe everything in a chaotic way. We need to find a structure among the impressions we get. So we are cutting our impressions in bits in order to make sense of it. But life is not like that. It's also a process. It's an evolutionary process. It's not a clear-cut limits between different life forms. It's a process, an evolutionary process, and it's a gradual phenomena. So there is a continuum of life, and so in that way, our definitions or our ways of trying to find a clear-cut definition is not always fit into how nature works. The same thing is with the species concept. It's also a difficult way of treating the world. That's the species concept is very much in our minds, but there is still something out there that it corresponds to. So it's always a challenge for the human mind to find this interaction between our minds and our concepts and what is out there in the outer world. And so that's the challenge. But perhaps the most difficult challenge is, if we go to the next slide, is our empirical ignorance. That we have actually only knowledge about one kind of life, and that's the life we find here around us on Earth. That's the only life we know about, and from that only single example or sample of life, we try to come up with a universal definition of life. So we are not really sure about if these ingredients or characteristics we find in life, if these are universal or if they are specific for that kind of life we have here. How could we know if this kind of life we have is specific or has universal ingredients or characteristics? So we can't really know that before we have a second example of life. So the whole challenge is to find the difference between true biogenic signatures or abiotic mimics, to find that's I would say the main questions for the philosophy of biosignatures. How we could make a difference between true biogenic signatures and abiotic mimics. That something looks like life, but it's not life. So we need to avoid false positives that mimics life, and also false negatives that real signatures of life are overlooked. So we should at least avoid these two fallacies when we are searching for life, and that's one of the main questions for the philosophy of biosignatures. And I will come back to that later on. So if we go to the next slide, my second problem that I would talk about is the question of the analogy of the Earth twins, as I call it. You could explain biosignatures or astrobiology as a huge analogy question. It's a question of an argument from analogy, that we are starting from the only example of life we know here on Earth, and then try to search for similarities out there in space. We're trying to select a number of features in life here on Earth in the source domain that we could call life here on Earth, and try to transfer these relevant properties from the source to the target. So we are selecting a number of characteristics and trying to find these out there in space. So we are lot of the exoplanet research nowadays is looking for a second Earth or an Earth analogy, an Earth analog, an Earth twin. We are searching for a planet with the same size as Earth, orbiting a star similar to our own sun, in the Goldilocks zone, and so we have a number of things that we think is crucial for life, and trying to find these environments out there. And of course, this is not it's not a valid argument if logically, but it could be a way of searching. Even though we find an environment completely similar to Earth, it's not, of course, a proof of that it must exist life on that planet or that environment. But it could be a way of starting searching for life, and it has some advantage with it. So if we are finding millions or perhaps billions of environments out there in space that is similar to Earth, if we can't find life on these planets, that discovery or lack of discovery will also need an explanation. Why can't we find life on planets even though these planets have the same characteristics as our own living planet? So the question here is, and the problem is, how could we know, and do we know all the necessary or sufficient conditions for life? Have we a complete list of conditions? And the analogy argument also restricts ourselves to one particular sort of life we happen to know, our own life. So we might overlook other forms of life or weird life that we will not find because we are not searching for. So it has some drawbacks. And of course, we need also to include stochastic events that is evolved in the evolution of life, the unpredictability of evolution. If not a meteorite had hit the Earth 66 million years ago, the dinosaurs hadn't been wiped out. So there are stochastic events also in evolution that we can't count with or could include in our predictions. So if we go to the next slide, I have just some examples from the history of astrobiology. The most one of the first great analogy arguments was made in the beginning of the 17th century when Galileo directed his telescope in 1609 towards the moon and found that the moon had a rugged structure with mountains and fields and a topography similar to Earth. So from that observation, many philosophers and scientists in the 17th century made an analogy or conclusion that if moon is similar to Earth, has the same geological or topographic features, maybe it will also have life. So if we could find environments similar to Earth, we could conclude or guess that it could also have life. So in the 18th century, Venus, the planet Venus, and later in the 20th century, Mars became a candidate for life because we found similarities between Earth and those planets. And if we can't find any difference between Earth and Venus, for example, why shouldn't be life on Venus if we find life on Earth? That's what the French popular astronomer Flammarion said in the 19th century. So we could go to the next slide, where my third question concerns is connected to this question. Is I call it the epistemic perception, that the observations we get from outer space is not something neutral. It's not something complete objective observation of the outer space that we just like a photograph or something. Everything we perceive or study in outer space goes through our brains. It's an obvious fact, of course, but everything we study and everything we are seeing is directed by our preconceived understandings, our preconceptions, our pre-understandings of things. So our knowledge forces us to interpret what we encounter in one way or another. So that we don't have knowledge about, we often overlook or can't really understand, or we can't even see it because we have no concepts of it or preconcepts. So a good example, there are a number of good examples from the history of astrobiology. Face on Mars, the Viking probe in 1976 took this image from the surface of Mars, and we could find a mountain that clearly looks like a face that has since then been called the face on Mars. But another probe in 2001 took a more detailed image of the same mountain and found that it was only our own eyes or our ways of interpreting the shadows of this mountain that made a trick on us. So it's just this face on Mars is not on Mars, it's in our minds, in our brains, how we perceive the world. And we are especially tentative, or we could easily find things that we are seeing around us. If we go to the next slide, you could, if you study the atmosphere of Venus, or the study of the atmosphere of Venus in the 19th century, it showed also how the mind tried to find Wolf, please, could you take the next slide? Here you see a number of pictures from Venus from the 17th and 18th century, where people or astronomers try to interpret what their senses conveyed. Some thought they saw an atmosphere on Venus, And some said that they saw mountains, and specific lights phenomena on Venus, in order to interpret these dim, small images that they got through the telescope. But the most famous example of this phenomena, if we go to the next slide, is the canals of Mars, which Schiaparelli saw in his telescope in 1877, and he saw a number of lines and structures on the surface of Mars that he called canals, that Percival Lowell later on made a huge catalog and a map of all these artificial canals that he interpreted it. He thought it was canals that the Martians use for transporting smelting water from the polar caps to the equator. So he had, or Schiaparelli, especially Percival Lowell, had an expectation what he thought he might see on Mars. If we have the expectation or the mindset that we are thinking that Mars is inhabited, should harbor life or even intelligent life, we are searching for traces that give us these interpretations. So Percival Lowell, he found what he were looking for, and that's a major problem or major challenge in our search for biosignatures. I've read a number of articles claiming that they have found signs of life on Mars. Even just a few weeks ago, came new articles claiming that they have found fossilized life on Mars. So when we are expecting to find life, we try to find all the traces that direct us to this conclusion, even though there is no real connection or real good arguments for what we expect. If we go to the next slide, Percival Lowell, he got a critique for his interpretations of what he saw in the telescope. The French-Italian astronomer Eugène Antoniadi, he said that that was just an optical phenomena happening in the brain of Percival Lowell. So if we try to find a pattern among a number of patches, and so this is an example how we connect these patches to become lines, even though there is no lines. We interpret these dim pictures in a way that is in line with our expectations. So if we go further back or we go to the next slide, we could see this phenomena in the distance. You see how these patches become lines. So it's an optical phenomenon. Finally, I have a fourth question or problem connected to the history and philosophy of biosignatures, which I call the semiotics of biosignatures. In fact, our search for biosignatures is a semiotic problem. It's a kind of semiotics. With semiotics, I mean a way of searching for meaning, the meaning-making processes, how we endow the environment or what we are perceiving with a meaning. So there are, it goes back to Charles Sanders Peirce, the American philosopher, who said that this process of looking for signs is triadic. The science consists of the expression that we could call then the biosignature, and the object, that is life. But the third thing in this triadic semiosis, or the semiotic triangle, is the interpreter, the astrobiologist. So we have the sign, that is the biosignatures, that refers to the content or the object, life, and the one who make this connection between the expression and the content is the scientist, the human being, the interpreter. So we can't rule out the scientist in the search for biosignatures. We are always involved in our studies of the universe. Our minds are always involved in this interpretation. So we need to be aware of our own situation in this. So if we go to the next slide, so it contains, the sign contains the expression that refers to the content, the living organism, that is identified by the interpreter. So what we need to do is to rule out other explanations of the sign relation. We need an explanation why we have connect the sign or the biosignatures with the life. We need have an explanation of this connection, but we should also be able to rule out other explanation for this connection, because the biosignature could be not a true biosignature. It could be something that refers to an abiotic process. But we need to make this difference. So the biosignatures we detect are only one way among many other ways of making sense of the data we receive from the outer space. So that's only one way we could interpret the information we get from the universe. We usually would like to find these biosignatures, but that's just one way of interpret the things that we get from the outer space. So these biosignatures exist so far as we find them meaningful, because we endow the world with meaning and try to find a meaning among all these expressions or impressions that we get from the outer world. So if we go to the next slide, so the challenge of this astrobiologist is to pick out the right properties of the signifier that direct us to the signified, the living organism. So first we need to pick out the right properties that are really true biosignatures that direct us to the object, the real biological processes. And the second is to have a reasonable explanation of the link between the signifier and the signified, and rule out other explanations. And these sign relations between biosignatures and the life, the content life, are in fact just three different ways of sign relations according to a classical semiotic approach. And the first is similarity, that's called iconicity, and the second is proximity, indexicality, and the third is convention, symbolicity. And I will say just a little bit these different sign relations, because the biosignatures that we're studying are, as I said in the beginning of my talk, a vast different kinds of phenomena, not just to its content, but also to its expression. But it's basically three different sign relations that we could talk about in the philosophy of biosignatures, I would say. So if we go to the first, to the next slide, and the first sign relation, the most basic one is the icons of life, or you could call it bio-icons, the biosignatures that share a similarity with living organisms. And the most typical example of this is fossilized life. For example, when Nicolaus Steno in the 17th century found shark teeth in the mountains of Tuscany, he drew the conclusion that this was remains of once living sharks that have lived up in the mountains, and the mountains have been actually the sea floor in the earlier in the history of the Earth. So fossils are a typical example of icons that is things that share some visual morphological similarity in structure with a living item. But it could also, bio-icons could also be chemical. It could be similarity between expression and content by sharing some chemical properties. It could share the same chemical properties, the similarity in that way. And it could be also molecular fossils, fossils of molecules, not the real molecules that are included in living organisms. It could be molecules that we find in a fossilized state. So again, the problem is how to distinguish real remnants of living organisms from structures that just mimic living forms. Are they really fossils or pseudo-fossils we find? And a famous example is the Alan Hills from the Allen Hills meteorite, where we find a structure that looks like something organic, but even though it looks like something organic or like a fossil, it's not really always that. It could be something that mimic a fossil or a living thing. So similarities in morphology are not proof of life, and similarities are not enough to be sure that there is a real connection between the fossil and the living organism. More important is the next example of sign relation. We'll go to the next slide. It's the index, the indices of life. And indexes are biosignatures that have the connection to their objects, the living organisms, by contiguity. In the same way as Robinson Crusoe, when he was walking on the shore and found a footstep in the sand, he stood like thunderstruck, it says, or as I had been seen an apparition, Robinson Crusoe said. So if he found this footstep, he drew the conclusion that this footstep was made by a living human being. It's not the shape of the footstep that directs us to make the conclusion. It's the contiguity that is between. The foot is not looking like a living being. It's a trace of a living being. So with bioindices or the index concept, we try to establish a connection between the sign and the content, between the biosignature and the living organism. So that's we come closer to a better understanding of the connection between the biosignature and the content. So there is a causal link with the life form. And it requires also empirical knowledge of the recurrent connection between the sign and what it refers to. So we need empirical knowledge about this connection. And it could be tricky when we are searching for life that we don't know about. So if we go to the next slide, bioindices could be fossils that record the activity of an organism, and it could be biogenic minerals, and it could also be atmospheric. So the challenge, once again, is to distinguish bioindices from features that are a result of an abiotic process that mimic the biotic behavior. An example is the stromatolite. It's not life in itself. It's not a fossil of the real organism. It's a structure made of cyanobacteria. So that's an example of a bioindex. But how could we be sure that this structure has not a abiotic explanation? That's the challenge. If we go to the next slide, I think we have the most one of the most interesting and challenging things in the near future. It is the study of spectroscopy, how we could study the light from other planets, how we could finding spectra indicating the chemical composition of the atmosphere of distant planets. So from the remains of chemical traces in the atmosphere that we could discover through remote indirect sensing, we could find gases in the atmosphere of that planet we are studying that are produced by life, like oxygen, ozone, methane, carbon dioxide, that could be produced by life. But we should also be aware of that we need to rule out other explanations for these gases to be there in the atmosphere, because there are a number of abiotic geological processes that produce these gases. So how could we come to a certainty or a level of certainty that is good enough, so we could conclude that this planet has biological processes going on in the surface, on the surface of the planet. But it could also be the combination of these gases and this equilibria of these gases that could give us hints that this is not it must be a biological process behind it. But I think that would be very interesting the next few decades with the new telescopes that we could study the atmosphere of exoplanets in the near future. If we go to the next slide, we have also what we could call techno indices. It could be enough to say here that it's not always biological processes we might find out there in space. It could also be indices of technology that is sort of second order index that indicate technology which in its turn could indicate life. Could be artificial molecules, environmental disequilibrium, radio signals. It's the most famous example of this techno signatures that could be discovered. So we come to do my last symbol or my last sign relation. If we go to the next slide, is the symbols of life or biosymbols. That perhaps is not so relevant for astrobiology in itself. It's more a question of SETI, the search for extraterrestrial intelligence. But that's the third way of finding a sign relation is through symbols. And symbols are signs that are conventional, that the connection between the expression and the object is a convention. For example, the letter A, the sounds A, the connection between the letter and the sound is a mere convention. It's nothing you can see in the letter A that you need to pronounce it in the way we do it. It's a convention. It's something that we have decided together, and we need symbols in order to discuss more abstract, complicated things. So that's the challenge in the SETI research, how we could be sure that the radio signals that we receive the first question is, could we even see if it's a natural or artificial sign? But the next is to find out if it contains a message, if it has a meaning, a symbolized meaning in this radio signal, because the radio signal in itself doesn't say anything more than electromagnetic waves. If it should also have a message, then it's based on a symbolic relation between the sign and the content. And that's why it would be very difficult to decipher radio signals in the near future or in the future, because we don't know about this conventional sign relation. Yeah, so I come now to my last slide, to my summary. So just to wrap up what I tried to say today, that there seems to be something out there in outer space that we are studying, that is the object, that makes or follows of a reaction, the expression. And this connection between the object and the expression is invented or discovered by an interpreter. So we human beings are trying to interpret this huge amount of possible or potential signs out there, and trying to pick up these signs that we think has a connection with the content that we're searching for, namely life. So the general epistemological problem is to recognize the signatures as meaningful, as expression that refers to a content, that is life. And then to establish with a certain degree of certainty the connection between the expression and the object. We need an explanation. And we also be able to rule out other explanations for the signatures that are not of biological nature. So that always will be the challenge for our search in biosignatures. And everything goes back to who we are and that it is to we human beings who are searching for these signs out there. As Arthur Eddington said, we have found a strange footprint on the shores of the unknown. We have devised profound theories, one after another, to account for its origins. At last, we have succeeded in reconstructing the creature that made the footprint, and lo, it is our own. So when we are searching for life out there in space, I would say we are searching ourselves, and we are going out and searching and discovering our own minds. So that's what I would like to say today, and thank you for listening. So if we have time for questions, I'm happy to try to answer that.
Okay, David, many thanks for this talk. As usual, I would like those who want to ask a question to put the camera on so that I can see them. Or if you don't really want to do that, or you can't do that, then please then put the question into the chat so that I can see it and read it out for you. I think there is Peter Vickers. You might want to Peter Ickers, who might want to ask a question.
Okay, thanks very much. Yeah, that was lovely, and yeah, there's so much to explore here. I'm just going to pick up on one thing, and I wondered about making a comparison with the definition of a planet, because in that choice, I think most people agree that there was no fact of the matter whether Pluto was a planet in some sort of objective sense, but rather we had a choice to broaden the concept of planet in such a way that it would be included, or to narrow the concept, you know, to bring in a definition that would exclude it. And I wonder if could we apply that thinking to the discovery of some kind of alien phenomenon that we find maybe on the surface of Mars. So, you know, we may be faced with sort of, if you like, intermediate cases. They're definitely not just rock, and they're definitely not clear examples of life. We get an intermediate case, people are bound to ask, well, is it life or not? And then they'll start looking at definitions of life. And isn't it really the case that we would have a choice in that situation? We could choose to broaden the concept of life in such a way that it would be included, or we could choose to stick with a rather narrow definition in which it would be excluded. But you know, either way, we've still found something amazing. It sort of doesn't matter whether we choose to define life in such a way that it is life or not.
Yeah, I would say that, of course, all concepts we are using in science are, in one way or another, is a convention. That's something that we agree on. We have a definition of something, and then we stick to that. Problem is that we will also overlook new instances or weird forms of life, for example. So it will limit us in our research. That's why some philosophers say that we should get rid of definitions, the life definition at all. We don't need it. We should be more open-minded and don't restrict ourselves to a certain definition, because that will give us we will miss or overlook interesting information if we are. So if we find phenomena out there in space that we think could be something similar to life, it would be always, we have to redefine our concepts. So if we have a concept for now, for Earth, like life, then we need to redefine this definition, probably, if we find other examples of life out there. Yeah.
Okay, so let's see if there is another in the chat. I don't really see any question in the chat, but maybe somebody wants to have a look.
Quick follow-up, maybe.
Just a moment. Yeah, anybody asking a question, wanting to ask a question?
Peter had following up, or
yeah, please go ahead.
I just thought, yeah, I mean, I agree with you, but I thought one thing to distinguish was that those who want to sort of, I guess, do without definitions, but there are those who think that we should have lots of definitions because any one of them might be useful in a given context. So then the definitions of life wouldn't be competing as such, but rather, you know, they would all be welcomed as long as maybe you could see some work that they could do scientifically, you know. So I guess in that case, if we found some strange phenomenon on Mars or something, the right answer to is it live would simply be on this definition it is, and on this definition it isn't. Yeah, there would be perhaps no fact of the matter.
No.
I don't know if you disagree.
Yeah, no, I agree what you are saying, and I think it's the same with the Earth twin analogy, that we could have a concept of life. Its strict concept, definite definition of life. We could have that. We could construct that and follow that, and we could use it for searching of life, searching for these kinds of phenomena that we call life. So it could be a heuristic way of searching for these kinds of things, a way of restricting our research in a way. But it's still, the problem is that we will overlook other interesting forms of weird life, probably.
Okay, thanks, and thanks for the talk.
Thank you, Peter. Yeah.
Okay. Any more questions? If not, I would like to thank David again, and we then have the next seminar in 14 days, and this will be announced in the different channels. So we're looking forward to see you then again in 14 days.